Hello student, my name is Anjali Tripathi and I am a physics teacher. I am teaching physics from last 17 years of various classes like BSc, MSc, 11th and 12th. Currently I am PGT physics, means I am teaching 11th and 12th, and here I am presenting you a topic that is based on a capacitor, and our topic is capacitance of a capacitor. Means how can we find out the value of capacitance of a capacitor. So let us start now the topic. Okay, so we know that the capacitor. What is capacitor? Capacitor is a device which capacitor is used to store electrical energy. Okay, means it is used to store the electrical energy. In which form it store the energy? It store the energy in the form of electric charge. Okay, so we know that it consists of two plates. The plates are made of conductor, means these are metallic plate. Okay, so basically this is the two-dimension diagram. So these are the metallic plate. Okay, one as it store the charge, one of them become positive and the second will become negative. Okay, now so the plates are basically like this. It means it has some area. Okay, suppose the area of the plate is A and the separation between the plate is D. Okay beta, so how can we find out the value of capacitance? So basically we know that charge stored in a capacitor is directly proportional to the potential. Okay, so if we remove this sign, then we get a new term, that is the capacitance of the capacitor. So what we know that capacitance is Q upon V. Is it clear? So if we want to find out the value of capacitor, we have to find out the value of Q upon V. Suppose that this positive plate has the charge Q plus Q, and this negative plate contains the charge minus Q, means both of the plate has same magnitude of charge but it is of opposite polarity. Is it clear? So first of all, if we, and one more thing, as we already discussed, that suppose the area of the plate is A. So we already studied that the sigma, what is sigma? It is the surface charge density. It is charge per unit area. The sigma is बच्चों surface charge density. Is it clear? And its value is Q upon A. So I hope you understand till now. Okay, so these are the two plate of capacitor. Okay, we said that this is the positive plate and this is the negative plate. Is it clear? Okay, so now we know that the electric field is there due to the positive charge, and we know that the direction of electric field is basically radially outward to the positive charge, and because this plate contains positive charge, it means it has its electric field, and the direction of electric field is like this, and in this region it is like this. So if we divide here three region, 1, 2 and this third region, the first region is left to the positive plate, the second in between both the plates, and the third region is right to the negative plate. Okay, so this is the electric field that is radially outward to the positive plate, and electric field due to this negative plate is towards the plate. Where it is? Towards the plate. Okay, like this. Okay beta. Okay, now so we know that we already studied earlier that the electric field due to a plane sheet to any point P is equal to, what is the electric field? It is equal to sigma upon 2 epsilon naught. Okay, so again, now for the first side, for the first area, we can see that the electric field due to positive charge is away to the plate, means the E plus is in this direction, and the electric field due to this negative plate is towards the negative plate. And because the electric field intensity is only depends here only on sigma and epsilon naught, it does not depend on the distance. It means in the first region, electric field due to positive and due to negative charge get cancel out. Okay, because the magnitude are same and the direction are opposite. That's why electric field, the resultant electric field here is 0. In the same way, if we see the third region, what we see here, we see that in the third region the direction of electric field due to negative plate is along the plate, means this is the electric field due to negative plate. Okay, so what is the direction of electric field due to this positive plate in region 3? In this third region, the electric field due to this positive plate is outward. Again, the value of electric field is sigma upon 2 epsilon naught, and the direction is opposite in third region too. It means that the resultant electric field in third region is also equal to 0. Is it clear? Okay, now look at the second region. See, the direction of electric field is the same, means towards the positive to negative plate. So due to positive plate, what is the value of electric field? Sigma upon 2 epsilon naught. Yes. Okay, now for this negative plate, what is the value of electric field? Sigma upon 2 epsilon naught. Because both of them are in same direction, the resultant electric field, okay, what its value will become? E plus plus E minus. Okay, so what it will become? Sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught is equal to sigma upon epsilon naught. So in the case of capacitor, here one of the plate is positive and the second is negative. The electric field outside the plates, means here and here, in this first region and in this third region, the electric field, the resultant field is 0. Only field exists between this second region, and the direction of field is from positive to negative, and its value is sigma upon epsilon naught. Okay, so now, okay then, so what we want to find out, what we studied earlier, we studied that the capacitance is Q upon V. It means that to find out the value of capacitance, we have to find out the value of V first, means the potential. Okay then, look it here. This is the capacitor, and here the distance between them is D, and electric field between them, we just find out the value of electric field between them is how much it is. It is E is equal to sigma upon epsilon naught. It is the electric field between the plate of the capacitor. Okay, so now we know that what is the value of E, what is the potential. Potential is electric field intensity, okay, into distance between the plates. Okay, what is V? V is E into T. Okay, now put here the value of E. The value of E is sigma upon epsilon naught into D. So here we get the value of V. So now put this value in that formula we described earlier, and that is the C is equal to Q upon V. Okay, so now C is equal to Q upon V. Now put the value of V, so it will become Q upon sigma D epsilon naught. We know the value of sigma, we already discussed it. We know that the sigma is Q upon A. It is the charge per unit area. So now put this value, what we get? We get here Q epsilon naught A upon D. Okay, so what is the value of C? The value of C will become C is equal to epsilon naught A upon D. Is it clear? Okay, so here what we consider, we said that there is no medium present between the plate. Does we discuss any medium? No, we not discuss. Okay, we only said that the two plates of opposite polarity are kept at some distance. This is the capacitor. Okay, so in this case, here we take epsilon naught. So look at here the term the capacitance. What are the result? The capacitance depend on, first thing, area of the plates, area of the plates. Okay, second thing, separation between the plates. Okay, and the medium, this is the epsilon naught. If we take any other medium, then we will take the epsilon. Okay, so medium between the plates. Okay beta, so this is the basically capacitance of a capacitor. Okay, what is the unit of capacitance? The unit of capacitance, what is its unit? Its unit is farad. Okay, so this is a basic topic. Now in the next video we will discuss any other topic. Okay, have a nice day.